So airplane weight and balance is what we're going to be talking about, and the overview of this is going to be basically identifying what the different parts of a weight and balance thing is, and different terms that we're going to use so that you can correlate that with the actual airplane and the proper way of using it, using your chart and stuff like that. So some of the terms we're going to start out with are going to be the reference datum, and this can be located anywhere that the manufacturer chooses. On the Cessna, it's right behind the firewall, so it's going to be like right here. And then with that, anything that's forward of that, like the engine, is going to be negative for the to be able to calculate that. So this would be a negative arm, and then if anything is behind it or aft, it's going to be positive. Common locations for this, so like I said, on this one it's the firewall, and then sometimes it can be the nose or the leading edge of the wing, or even the head of the nose, like an imaginary reference datum.
This is an 8, it's right here. It's the prop flange or whatever.
Really?
It's not weird, yeah.
That is crazy.
That's why our arms are like 45.
Is it a light sport?
Mm-hmm.
Okay. Yeah. And stations. So stations are going to be different places on the airplane. A station can be like the pilot's seat. It could be the rear seats, the baggage compartment, various things like that. And an arm. So an arm is going to be the horizontal distance in inches from the reference datum, aft or forward. And if it's forward, like I was saying earlier, it'll be negative. If it's aft, it'll be positive. If your datum is going to be ahead of your nose, that means that everything's going to be positive. So I'm assuming everything on the 2008 that you fly is positive.
Mm-hmm.
And then a moment is going to be a force that's going to try to cause an object to rotate, or it's going to be a force that actually does cause an object to rotate. And it's to calculate that, you're going to find the weight of something, and then you're going to have the arm. So it could be whatever station, maybe your pilot station's 37 inches, and then you would multiply your weight. Maybe your basic empty weight's like 1600 times 37. That's going to equal your moment, and that's going to be the force required to rotate around that point.
Wait, so if you said that the force, the moment is a force that it wants to rotate about it,
It's a force that causes it, or it tries to make it rotate around that.
Right. Why would there be 600 pounds in the pilot's seat? You said that you could have like at the station, like the station from like the reference datum to like that arm would be like the amount of weight at the pilot station times your arm. Why would that be 1600? Wouldn't that just be like your CG if it was 1600 weight empty weight? Because it wouldn't be at your pilot station, would it?
So it would just be like that times. So let's say that you have like 1600 or whatever, and then times the 37, and then that number that you're going to get from multiplying that is going to be the force required to rotate about that.
Right. But I was just wondering why you use 1600 for the pilot seat in that station. Was that just like basic?
Oh, no. I was thinking like just the aircraft in general.
Okay. I was just wondering, so I was like, I don't know if you know
that wouldn't be. So there's not a 1600 pound pilot.
Yeah.
Actually, I better clarify on that.
Yeah, because I was confused. I was like, where'd you get? Because
that would be like for the entire airplane.
That'd be like the basic, like
yes.
the CG of a
yeah.
plane with anything.
Okay, so from the pilot seat, and let's say that it's 37 inches, like we said, and I weigh 200 pounds. So 200 times 37 would be the force of that equals the moment that is required to rotate about that.
Right.
Yeah, good catch on that.
So I was like, because I thought maybe that the basic empty weight CG is at the pilot seat. That's why I was asking.
Yeah, no. And then, we were talking about the CG. So that's the point of the airplane, so that it would balance. If I tied a string to it and just let it dangle, it's going to balance right here, and that's going to be your CG. And that can move forward and aft depending on your weight, and we'll talk about that. To find your CG, you are able to just take your moment and then divide that by your weight, and then that's going to actually give you your CG.
Yeah, your total moment divided by your total
Yes.
weight. Right, okay.
Or it can give you a CG for a certain
For a
station.
certain station.
Yes. And CG limits, this is going to refer to the extreme forward or the extreme aft points of where the CG can be. And this is going to be determined by the airplane manufacturer. And it's going to be located in your POH. You'll be able to tell. Usable fuel is another term that we're going to be talking about, and that is your fuel available for flight planning. So it's not going to be anything that you can't use. So things that you can't use is going to be called unusable fuel, which makes sense, right? And the fuel in the tanks that can't be safely used in a flight or drained onto the ground is going to be your unusable fuel. So it's just like your residual, hardly anything, right?
You can move like the lines.
Yeah.
Like the fuel lines.
Yeah.
You can't get out.
Right. And then basic empty weight is another term, and a lot of times you'll see basic empty weight referred to as BEW. So just understand that that's what that means, just another aviation acronym that you're going to run into. And that's going to be the weight of the airplane, all your optional equipment, your unusable fuel, and then your full operating fluid, so your oil is what that's referring to. And hydraulic fluid would be included with your other fluids. Payload is going to be the weight of occupants, cargo, baggage, whatever you're carrying. It's basically saying if this airplane has a payload of, I don't want to say anything that's outrageous and not true, but let's just assume 2,000 pounds.
That's your payload? Or what's that?
Let's imagine that 2,000 pounds is your payload.
Okay.
Maybe not for this airplane,
Right.
but just in general.
Yeah.
So that means that this airplane can carry and transport, do everything with 2,000 pounds effectively. And that would be the payload of this airplane if the payload was 2,000.
Isn't it the max gross weight minus the base empty weight?
No, we're going to talk about that in a second.
Okay. I'm just thinking, is that the payload?
No,
Okay.
that's your useful load.
Okay.
So that's actually what we're talking about next. That's going to be the difference in your total weight, your takeoff weight, or it could be your ramp weight and then your basic empty weight.
Okay.
So that's your useful load, and it's going to be basically you and everything that's going to be required to make the airplane able to be used, essentially, if that makes sense. Okay. And another thing is going to be our max ramp weight, which this one's a little bit different. You'll see your max takeoff weight and your max landing weight are going to be the same. So with your max ramp weight, that's going to be a little bit heavier, and that's the maximum weight for you to be able to taxi, essentially. Because when you have your max ramp weight, it might be like 8 pounds higher than your takeoff weight, and that's to account for the fuel that you're going to burn when you're running up.
Right.
So you're not actually going to take off with that, but you can taxi around with it. So it could be kind of confusing.
Right.
Seeing that different number. And then with your max takeoff weight, that's equal to your max landing weight most of the time, with the Cessna at least. And that's your max weight approved to start your takeoff with them. Just you're on the runway, you're about to go, that's the max. And then same for landing, it's the max that you can actually touch down and land with. Your max zero fuel weight is the max weight exclusive of the usable fuel. So drain all of your usable fuel out of there, and then that would be your max zero fuel weight, is whatever that's rated for according to your POH.
Okay.
And standard weight, there's going to be certain things that are going to not be on a chart that you might be looking at. Like you should understand that your gas is 6 pounds, or maybe if you're in a jet, that fuel is 7 pounds. Your oil 7.5, things like that. They're just understood values. And with weight and flight performance, so what do you think would happen if you had a heavier airplane? Like, let's say you're in limits and your airplane's a little bit heavier. Maybe you're at max weight right now.
Okay.
You're 2550.
Okay.
What do you think might happen?
When during takeoff?
Yeah, or anything. Takeoff, flight, landing, whatever.
Should it take longer to take off the ground, get airborne if you're going faster? If you're landing, you might create damage. Depending on, if you're in limits, you shouldn't create any damage, but you might it might be harder to flare. I mean, I don't know.
Yeah, so that's really good. With what you said at first, when you have a heavier airplane and you're trying to take off,
You're gonna,
what we've talked about before is creating lift.
Mhm.
And if you're heavier, you're going to require more lift than if
Right.
you're not as heavy.
Alright.
So it would make sense that a heavier airplane takes longer going down the runway because you've got to go faster before you're able to create lift,
Right.
which could cause a problem if you're maybe at a shorter airport or
Marlin.
you need to get up over some trees.
Right.
Marlin, good examples of that. And then your performance is going to be reduced when you're in your climb
Right.
or if you're cruising, because just think it's gravity basically. You've got more weight and it's harder to get up and climb,
Right.
and it's harder to just cruise because you've got more weight that you're carrying through the air. Another thing that can happen is you could overheat in your climbs because the engine's going to be working too hard to get you there. You're gonna use a lot more fuel if you're heavier than if you're lighter also. And with you using more fuel, that means you're gonna have a decreased range. So maybe you had 6 hours of fuel before, now you've got 4.
Right.
So that's something to really take into account. And when you're landing, like you were saying, that is true. It would be harder to flare.
Mhm.
With weight and structure, it's very important to really pay attention to your limits when it comes to this, because it's not going to just happen instantly like that. It's going to happen over time because you stress the airframe a lot longer, and then one day some poor soul rents your airplane because you've been stressing it out, and maybe the fuselage cracks or the wheels can't take the load when you come in to land,
Right.
and then you've got a total aircraft on your hands. So that's no bueno. And an airplane is going to be certified to withstand certain loads based off the category that you got it in. So maybe if you're in the normal category in your POH, you can see, it's certified for this load and this amount of weight. But maybe if you're in a utility category again, you're going to go practice spins. It might be less because you don't want to stress the airframe. And it's really hard to detect these things, so it's kind of important to abide by the honor system on that, because it could really ruin somebody's day. With weight and balance control, who is responsible for weight and balance control?
Flying command.
Piloting command. Piloting command is always responsible. So doesn't change here. And the reason the piloting command is responsible is because there's a printed weight and balance that's signed in the POH in the aircraft, and then you're able to use that and reference what weight that you're adding to it. So there's really no excuse for you not to be able to do the math, calculate it, and then flip to your little page in your POH and run your fingers together on the chart and say, I'm in limits or I'm not.
Right.
So that's easy to say that it's the responsibility of the pilot command. And let's talk about effects of having a forward CG. I've actually got a website right here. I'll show you on my phone. I've got it pulled up. So check out this little graphic. And on there you can move the CG around. So you can move it forward and then you can move it aft, and you can see how the airplane is going to react to how the CG would be in a different place.
Oh, that's interesting.
So you can see if you put it super far forward, it's going to require the tail surfaces to produce a greater download, and that's going to add to the wings needing to create more lift.
Right, super far, it's an increase the induced drag.
Yeah, because you got it all the way forward. You're basically a lowrider at this point. And that's also going to increase the drag that you've got because lift increases proportionally with drag.
Right.
This can also lead to a higher stalling speed, which is what we do not want. We want our stall speed to be as low as possible.
Right.
And the airplane is going to be more controllable in this because you've got a longer arm, making the elevator more effective when it's kind of riding like a low rider like this. And it kind of actually, this is a bad model, so it sits like a low rider anyways. So you could just think that this has got a super forward CG maybe. And then we were talking about earlier, you're going to have a higher takeoff speed. Now let's talk about if you have an aft CG. So I've got this arrow drilled all the way to the back, basically sitting up perfect, and this is going to give you like a faster cruise speed because you're not making as much lift and drag. It's going to have a lower stall speed because it's directly the opposite of what the forward CG was. And these are kind of like good things about it, but it's really not good. It's actually worse to have a further aft CG than it is to have a further forward CG. And the reason because of that, what do you think it is?
No, we're talking about stalls.
Yeah.
But no, I was thinking about something before. If you have a further back CG, doesn't it? I feel like if you have forward back CG, then doesn't it sit further back like this?
Well, think of what the CG is. The CG is where if you had a string tied to it, then that's where it would bounce from.
Okay, and the center of pressure is.
It's not necessarily saying where the aircraft is going to have more weight or less.
You're right. Okay, thank you. That makes sense.
Yeah. So if if a CG's back here, then you're going to have a really nose low attitude.
Got it.
And if a CG's up here, you're going to have a really nose high attitude.
But if you have a CG that's back here, it's easier to stall but harder to recover, right?
If you have a CG that's further aft, it's going to be harder to stall and harder to recover.
Why would it be harder to stall?
It's going to have a lower stall speed.
Oh, I'm thinking about.
So you're going to have maybe not harder to stall. Harder to stall is probably the wrong phraseology for that, because you can stall in any condition.
Right.
But
if you have a CG that's back here and it's pushed down. Okay, hold on. Keep going. You keep going.
No,
I'm trying to think, because now I'm confusing myself, because if you have a further aft CG, it's easier to stall because your nose. Now I'm confused. Because I know it's harder to recover because your CG's back.
It's
here.
harder to recover because you've got to push down.
Right, you can't push down. Right, so wouldn't it be easier to stall too? Because if it has a tendency to lean back like this.
That's if you got a forward CG though.
Right, that's why I'm confused.
Just think about CGs as like, just put your fingers anywhere on that airplane and then hold it up, and that's gonna be your CG wherever you put your fingers. So right there.
Versus here, okay.
So look at your attitude when you've got your CG up there versus when you've got it back there behind the wings.
Right. So then, okay, because we were talking to Richie about this not too long ago, and he was saying that if your CG's further back, it's easier to stall.
I know it's harder to recover.
It's harder because if it's easier, it's hard to recover because you've got to push so much nose down.
Yes.
That means obviously there's a lot of back pressure. So then it'd be easier to stall because you don't have all that back pressure naturally.
But that's depending on your angle of attack, not as much your CG.
Right.
Let's just look it up. I've got my P-hack over here. I'm just gonna go to the index. Alright, center of gravity is in chapter 10. And let's find with an aft CG. Okay.
Might not be in there. This might be just not about. It's probably more like aerodynamic kind of stuff.
I feel like it should be. This is a lot of just being able to calculate it
Right.
and weight shift formulas and stuff like that. Let me figure that out, and I'll get back to you. But I do know that it's harder to recover from the stall if you got
Right, and I know that's right because
But it does make sense to me that it would be easier to stall with a forward CG because you've got a nose high attitude naturally versus.
Right, and that's what I'm confused about, because I don't think I've ever heard that.
Yeah.
I don't know that I've ever heard that, when you have because if your forward CG gives you a nose high attitude, then obviously it's gonna be easier to stall.
Yeah.
But I don't know that I don't know, I feel like I have had a ground in a month, so I have no idea. We'll continue, we'll come back.
Okay.
We'll look it up.
Yeah. And well, just continuing off what you said, it's way harder to recover, and it's not just a stall; it spins also, which a spin is a byproduct of a stall. So you
Right.
could kind of lump that into the same thing. And what it does do, you could look at it as a benefit. It's going to give you a shorter takeoff ground roll because your nose is more down, and you've got you're just going to be able to lift up off the ground easier because you're not going to require as much lift as if you had a forward CG when your tail was sitting low, and it's going to have more downforce on it.
Okay.
So it's going to be just in more of a natural state of, like, imagine it's just going straight down the runway instead of kind of canted back like this to where it's going to require more lift. So when it comes to computing weight and balance, I got some paper right here, and it's super easy. You're a Baylor student, so I'm sure that this is going to be child's play to you. But just for example, let's say that we used 1600 earlier, right?
Mm-hmm.
And then it's a good moment.
30,000. No, do 32,000.
32,000.
Yeah, because I know we divisible by 16.
Okay, so 32,000, and then maybe we're both in the front seat. How much do you weigh?
160.
160. So I weigh 200. So we got 360 pounds up front. We're flying today, and let's say that our arm is 37. Let's say that we've got nothing in the back seat, and that arm might be 73.
Mm-hmm.
And maybe we've got, 318 pounds of fuel.
Okay.
Maybe we're full, and maybe the arm for that's 48. And let's just leave it here for now,
Okay.
just to keep things simple. And nobody's going to ask you to be a mathematician, being a pilot. So go ahead and whip out your calculator. And what you're going to do, you want to find out what's your basic empty weight.
It's 20.
So it's going to be 20.
Yeah.
32,000 divided by 1,600.
That's 20.
So 20.
And then
360 times 37.
it's 13,320.
13,320.
And then that's
0. And 15,264, right?
15,264.
Okay, 15,264. I'm really good at dividing or at multiplying by 318.
13, 20 plus 15,264. 6,584.
So what you just did, you added up all of the moment.
Oh, sorry, you didn't tell me that.
Yeah. So you took the 32,000, which was the original moment, the 13,320, that was your moment from being in the front seat, and 0 was your moment in the back seat because we don't have anything back there.
Right.
And our fuel created a moment of 15,264.
Right.
And what did you say you got for that value if you added those all up?
6,584.
All right, 65.
60.
Okay, 60,584.
Yeah.
Okay. And now for this one, you're going to add your
Right.
total weight,
Okay.
and your total weight is going to be all of these numbers in this left column that we drew. So we got 1,600, 360 is how much we weigh, 0 in the back seat, 318 for the fuel. How much is that?
2,278.
2,278. And now, with some simple algebra, we need to find out what our CG is going to be with us in the front seat, 318 pounds of fuel, and our basic empty weight. And what is 6584 divided by 2278?
60 to me 26.56.
26.6. And now that we've got our value of 26.6, we can pull out our POH and look and see if we're going to be in the envelope for whatever thing that we're going to do today. Let's say that we're just going to go on a basic training flight, do some steep turns. We're going to go and we're going to look at the normal envelope, and then we're going to take that 2278 is going to be on the left side of a table, and then our CG, which is 26.6, is going to be at the bottom of the table. And then you're just going to put these two dots together, and then that's going to see there's this envelope right here, and if it's inside of that envelope, you're good to be able to go fly. If it's outside of the envelope, then you can't fly.
Right.
But you've already spent a lot of money to be here and you want to go fly, so we need to figure out how to put it in the envelope.
Right.
And how we do that is through a weight change and a CG shift, so that we can put our CG where we need it to be so that we can go flying.
Right.
And there's different ways to do that. If you need to have a different CG, you're going to take your weight to be shifted and you're going to divide that by your total weight. And then you're going to divide the different CG that you're going to need by the distance that that weight needs to be shifted.
Okay.
And there's various formulas that you can use for this. It all just depends on what you're looking for. If your total weight needs to change, this formula. Weight change, this formula, and so on. You have any questions about how that works and why you would need to do these things? Or anything about just weight balance in general?
No, I think you got it all.
Okay.